where we have to study about what are the different types of ciphers, or what are the different types of block ciphers and stream ciphers. Basically, in this particular chapter, we have to learn about the modern ciphers. In the previous chapter, we learned about all the techniques for converting the plain text into the ciphertext. Basically, in the first chapter, we studied about all the classical encryption techniques, wherein we learned about monoalphabetic, polyalphabetic techniques, their examples, different types of uh, examples under the monoalphabetic, under the polyalphabetic, like Hill cipher, Vigener cipher, Playfair cipher, and so on. So these were the techniques which used the alphabetical replacement with the other alphabets to convert the plain text into the ciphertext. The alphabets which we used were in some random manner, or we had some proper formula for it to convert the plain text into the ciphertext. So, all in all, what we studied is how to convert the human acceptable language into the machine language, we can say, or the language which cannot be easily understandable by any attacker, which becomes difficult for the attacker to get the original information. So, in this module, we will be learning about different methods of modern ciphers, or we will be learning about different types of modern ciphers which helps to secure your data, which helps to encrypt your data in different ways. So in this module, we will have to learn about the concept of the block cipher and the stream cipher. So let's begin with introduction to block ciphers, which are also considered as the modern ciphers. To begin with the explanation of block ciphers, first we will be seeing the concept of it. So for working with the block ciphers, what is required? The required condition for working with block cipher is a secret key. A secret key, which is a key used by the sender and the receiver for the process of encryption and decryption at their respective ends. So, when the sender is sending the plain text and when the sender is converting the plain text into the encryption process or into the ciphertext, the encryption process takes place, and the encryption process takes the help of the secret key, with the help of which the plain text gets converted into the ciphertext. And then that same secret key is used by the recipient to convert the ciphertext into the plain text. That is the decryption process. So in the figure you can see the sender converting the plain text into ciphertext with the help of the encryption process, and for the encryption process it does require a secret key. Similarly, at the receiver's end, the decryption process takes place. Receiver, when receives the ciphertext, it decrypts it, converts it into the plain text. For this process, it then uses the same key, which is the secret key used by the sender for the encryption process. So the secret key algorithms should be fast, and they are used for encryption and decryption of the high volume data. Secret key cryptography basically is divided into two types, and those two types are stream ciphers and the block ciphers. So both the stream ciphers and the block ciphers do use the concept of the secret key cryptography, wherein the encryption and decryption is taking place with the help of the same key, and the same key is shared at the sender's end and at the receiver's end. So first begin with the stream cipher. A stream cipher is what? A stream cipher is a type of a symmetric encryption in which data is encrypted one bit at a time, sometimes a byte also. See, when we are saying that a data is being transmitted over the network, that means a message is being transmitted over a network having number of bytes in it. So for providing the security to the data, what do we do? What do we have to do is we just have to secure the bit by bit data of the information which is being getting transferred over the network. So what does the stream cipher does? Stream cipher converts every bit of your plain text into the ciphertext, and the encryption of those bits takes place one by one at a single time. Here in the figure you can see the plain text is getting encrypted with the help of a key, and that key is nothing but is key stream generator. That key is being generated with the help of a key stream generator, which is nothing but a pseudo random byte generator. So for every encryption process, for every encryption of a single bit, what the stream cipher does is stream cipher takes the help of the pseudo random key generator algorithm to generate the random number keys for conversion of bit by bit plain text into the ciphertext. Then the ciphertext gets created, and when it is being received at the receiver's end, again the same process of decryption takes place, wherein again the pseudo random byte generators are used, that is nothing but a key stream generators are used to decrypt the bit by bit of the ciphertext into the plain text. So here stream ciphers does take the help of pseudo random byte generators to generate the key, to generate the unique keys for conversion of the bits of your plain text into the ciphertext, and the same generators then uses the keys for conversion of the decrypted, for conversion of the ciphertext bits into the plain text bits. So this decryption also takes place in the same manner as that the encryption takes place, wherein bit by bit conversion of the plain text into ciphertext happens. Similarly, in the decryption process, bit by bit conversion of the ciphertext into the plain text happens. So this is the stream cipher. We'll see how it works. It encrypts the plain text stream. A random set of bits is generated from the seed key. The seed key is nothing but the pseudo random keys called the key streams, which is as long as the messages, and it has to be because we have to convert bits, every single bit of the plain text into the ciphertext. So key stream bits are added modulo 2 to the plain text to form the ciphertext stream. To decrypt the ciphertext message, what we have to do? We just have to use the same seed key to generate the same key stream used in the encryption process. Then again we have to add the modulo 2 to the ciphertext to retrieve the plain text. This is the equation of converting the plain text into ciphertext and ciphertext to plain text. C is equals to P XOR of K. P is a plain text, K is nothing but your seed key. We just have to XOR, that is nothing but the modulo 2. Then we get P XOR K, which is then again XORed with the key, which is nothing but conversion of the ciphertext into the plain text, and then at the end we do get the plain text. Now let's begin with what the block cipher is. Block cipher is a type of a symmetric key encryption again, which operates an block of data. We have studied just now that in the string cipher, we have to convert each bit of the plain text into the ciphertext. That means for every conversion of the bit, we are utilizing the modulo 2 operator to convert it into its corresponding plain text. But here, in case of the block cipher, what do we do is, though it is a symmetric encryption process as same as that of the stream cipher, but here it doesn't operate bit by bit. What does it do is, it creates the blocks of the same sizes. The block length can be of any size. It can be of 64 bits, it can be of 32 bits, it can be of 100 bits, it can be of 128 bits or more. So generally the modern cipher typically uses the block length of 128 bits or more. Previously, it was not the case. The block size were of the smaller bits also. And the different examples of the block cipher algorithms we can say are the AES, Advanced Encryption Standard. DES is there, double DES is there, triple DES is there, RC5 algorithm is there, ID algorithm is there. In your syllabus, RC6 is not present, RC5 is there, IDEA is not there, but these are given as the simple examples of the block ciphers, which do work upon block size of your plain text, and that complete block then gets converted into the ciphertext instead of the bit by bit conversion of plain text into the ciphertext. So here, when the encryption process takes place, a single encryption process will takes place on the complete block, and that block will be of the same size for every round of encryption till the complete length of the message gets encrypted into the ciphertext. So plain text block is there. Suppose it is of 64-bit. Encryption process takes place. For the encryption process, one key will be there, and after the encryption process, the ciphertext will get created, and that ciphertext block will also be of the same size as that of the plain text block, that is of the 64-bit. The block cipher breaks the message into fixed size blocks, and those fixed size blocks then goes for the process of encryption. So what does the block cipher, how it performs its work? It takes one block of plain text at a time and transform it into another block of the same length, and for doing this it uses a secret key. Decryption is performed using reverse transformation to ciphertext, and again for the decryption process the same secret key is used for every block to convert it into the plain text. Most symmetric block ciphers are based on the feastal cipher structure, which I'll be explaining you in the next lectures. Hope you might have understood this concept of the modern ciphers, wherein we have studied about the two ciphers, string cipher and the block cipher. Thank you guys.